Hello everyone, I'm very glad to introduce you our research project, which is utilizing polarity analysis to evaluate the sentiment consistency of machine translation. We have 5 group members: 舒驰武、凯康、袁瑶、袁良宋、秦晨. Next slide, please. As you know that machine translation is a challenging task. You need to choose the correct word which has similar meanings to the corresponding word. Besides, different language has different text sequence. You need to adjust the sequence of the words and phrases to change it into the proper target language. The current evaluation method to judging a machine translation is the BLEU test, which focuses more on the accuracy of choosing the correct words and phrases in the target language, but does not care much about the sentiment consistency before and after translation. Actually, different language has different expressing habits. For example, the famous Japanese novelist taught his student to translate "I love you" into Japanese, and he says that normally Japanese will not say "I love you" directly. Instead, they would say like "the moon is so beautiful." So to translate this "I love you" indirectly into "the moon is so beautiful" is actually a more appropriate translation, which keeps the sentiment consistency before and after translation. So in our study, we decided to choose Twitter as our database to evaluate the translation sentiment consistency of Google Translate. The reason we choose Twitter is because Twitter has short messages and has abundance of the message and has multi-language message. So that would be a very good experimental material. And the Google Translate we chose is the representative of the most efficient machine translation tools. In speaking of the sentiment classification or the polarity analysis, we chose the Google BERT model, which is the most popular deep learning based polarity analysis model. You just need to fine-tune this model with our training data, and you can get an efficient polarity classification of a certain input, no matter English or Chinese. Next slide, please. In our project, we divide into 5 parts. The first is the Twitter data crawling. It's done by Kai Kang. The second is Google Translation. It's done by Qin Chen. And Google BERT model, Chinese model, and English model training are done by Shu Wu and Yuanliang Song. The last part, the data analysis, is done by Yuan Yao. Next slide, please. We crawl our data from Twitter using the Twitter API. After we crawled the tweets, we also did the data cleaning step by removing URLs, @signs, and hashtag, because in the social media Twitter, most of the tweets are informal language. It contains a lot of emojis and @signs and hashtag signs and the URLs. So we need to remove all of them. Next slide, please. In our experiment, we chose 4 groups of data. The first group coming from the BBC official Twitter account. In this group, we would like to test on the neutral languages or news. The second group is coming from by filtering with the keywords coronavirus, COVID-19, or virus. In this group, we would like to test our pipeline on combination of news and normal message and even hateful language. The third group coming from the Twitter user Fang Zhouzi, which is a Chinese popular scientist and who is primarily known about his campaign against pseudoscience and fraud in China. In his Twitter, there's a lot of aggressive languages and critiques. And the last group of the data was filtered by the keywords Dongsen, Animal Crossing, or the Animal Crossing, the full name. And in this group, we would like to test ability of our pipeline on the informal online language and informal abbreviations. Next slide, please.
I will introduce how the Google Translate work and how we use Google Translate to batch translate our our source language. The idea of translation algorithm used by Google involves encoder-decoder and recurrent neural network. Generally speaking, encoder-decoder is to encode the sentence into a vector and then decode the vector back to sentence in another language. For the recurrent neural network, the most popular ones are IST model and the GRU model. The key idea of recurrent neural network is that the current layer not only use the previous input information but also remember the prior information of the previous input. Next, we use Google Translate pipeline to translate our source language into our target language. For example, translate English to Chinese or translate Chinese to English. Our first step, since our first step of our project is to grab the data from Twitter either in English or Chinese, so then we save this data into CSV file. Before the translation, we need to convert all data into strings. So we need to change CSV file into Panda data frame, then to series and to list and strings. Afterwards, we use API offered by Google Translate to translate our source language into our target language as the code shown in the slide, the black part. When we get our translated strings, we need to convert these strings back to data frame again for the use of the next step.
The next step is using the Google BERT model to do the polarity analysis on the target language. As an introduction to the Google BERT model, it is a model based on the recurrent neural network, as Qin Chen introduced you before of the Google translation, also the recurrent neural network-based NLP model. And the key part of the Google BERT model is word embedding and bidirection. What is word embedding? Word embedding is generally using vector to describe the word. And you would like to use initial word vector times the hidden layer to get the word embedding process. After this combination, you will find that the word vector which has closer meaning, such as grape, apple, has shorter spatial distance comparing with the word has different meanings, such as apple and lemon. The second key feature of Google BERT model is its bidirectional. As we learned in our NLP class, according to the Markov assumption, that the current word's meaning or function or feature mainly related with its previous words. So that's the single directional NLP analysis. Because our calculation power is increasing today, the bidirectional analysis of NLP is more and more popular. It will consider not only the previous words of the current word, but also the words behind it. To save the user's time and computational power, Google provides several pre-trained models of Chinese or English. And what you need to do is just to fine-tune these models. It's a small batch of training process. In this process, the model will randomly mark some of the words from the sentence and predict the original vocabulary of the words based only on its context. Next slide, please. So to train our Google BRT model, Chinese model, we first download the Google prepared pre-trained model, and then download some training data sets. For the Chinese model, we use an online open source database which collects 100,000 of Weibo data. Weibo is a social media platform similar like Twitter in China. There's about half of these datasets are manually labeled as positive, and half of it was manually labeled as negative. And because the limitation of our computer, we only grab 1/10 of it and then divide it into training data sets and validating data sets. And we use about 3.5 hours to train or fine-tune our Chinese BRT model and eventually get accuracy of 90%. Next slide, please. Similarly, Yuanliang Song trained our English-based BRT model. He used the Sentiment 140 database, which is also an open source online database containing manually labeled Twitter data. Half of this data were labeled as positive and half of it were labeled as negative. And he also selected 1/10 from it and divided into the training data and validating data. He used 13 hours to train his model and eventually get over 85% accuracy. Next slide, please. So to recall how we divided our experiment data, we had 4 groups of original data. 2 of them are Chinese tweets and 2 of them are English tweets. And then we translate into English or Chinese. In the group 1, we mainly want to test if our pipeline works on the angry Twitter users or aggressive language using Twitters. And for the second group, we mainly want to test how our pipeline perform on the informal languages. And the third group of data are coming from BBC, which majority has neutral languages and very formal English. So we hope our pipeline works the best on this group. And group 4 are the COVID-related tweets. So this group of tweets containing both normal people discussion or message and the news. And the raw results of the sentiment classification prediction is as below. For example, the Prime Minister Boris Johnson has been moved out of intensive care but remains in hospital, Downing Street says. This is tweet content. And the 0.9937 is the probability of the classification of negative of this tweet. And the green labeled number represents the probability of positive classification of this tweet. So based on the comparison between these two numbers, we got the conclusion of whether to classify it as negative or positive. In this case, we classify it as negative. As you can see that this sentence does not have obvious sentimental related words, but it has been successfully classified into negative. So that means our model has good power. In the following, we would like to analyze the results and give you deeper analysis. Next slide, please. First of all, we use the word clouds analysis on each group of the data to compare before and after translation. Does the keywords still keep the same? Overall, the keywords are very good translated, but there are still some improper translations. For example, in Chinese, we call shutdown city Fengcheng, but it has been translated into closed city. It's not so good. And the abbreviation of coronavirus in Chinese, 新冠, was translated into new cron, so that's definitely a wrong translation. And the Weibo in Chinese means the social media platform similar like Twitter. It has been translated into microblogging. That's also an improper translation. Next slide, please. In group 2, we found similar results. There's big problems on handling informal Chinese abbreviation, such as the popular Switch game, Animal Crossing in Chinese. Online social media, people normally call it 动森 for short, which has been translated just out of its meaning. Next slide, please. The third group is English to Chinese translation. Since it's from the BBC, it has very high accuracy, but still has some failure on the translation retweet or the BBC Sports into Chinese. Next slide, please. The last group of data is also English to Chinese translation. As we can see that the retweet is also still a very big problem. So in the future, we might consider to remove the RT from the token collections. And there's also failure on the translation of Donald Trump. That's also strange because some Trump was correctly translated into 特朗普 in Chinese, but not all of them. Next slide, please. After the word cloud analysis, we got the general idea of how our pipeline worked. And after that, we did more statistical analysis on our data. First of all, we compare the sentiment consistency before and after translation. As shown in this bar chart, the blue bar represents the before translation negative to positive ratio, and the light blue part means represent the after translation, the negative and positive ratio. As you can see that overall there's more negative tweets than positive tweets. And after translated to English, the proportion of the negative decreased. The light blue bar was shorter than the darker blue bar on the left side. And after translated to Chinese, the proportion of the negative increased. As you can see on the right part of the bar chart, the light blue bar had higher than the darker blue bars. Next slide, please. So what was related with sentiment consistency? We don't know. So we can just barely guess, and we think maybe it related with the tweet length. That's why we did this statistical analysis. We first got the average tweet length of each tweet in each group, and then we compiled it with the sentiment consistency of each translation. As you can see in this picture, the blue line represents the positive differentiation between before and after translation, and the dark green line represents the average length difference before and after translation. As you can see in this picture, the more difference in the average length before and after translation always leads to a bigger positive differentiation before and after translation. So we can conclude that the sentiment consistency of translation might relate it with the average length of tweet. So in the future, we could dig deeper to perform the statistical correlation test between the Twitter length and sentiment consistency in order to prove our hypothesis. Next slide, please. So in conclusion, we successfully established an automated pipeline to evaluate the sentiment consistency of machine translation. And we use both English and Chinese BRT model to do the polarity analysis. Both of them has very good accuracy or performance. After that, the sentiment consistency of the translation might be related with the average tweet length. That's a big guess, and we also treat it as a very big, the most important discovery in our research. So in the future, we could perform statistical tests of the correlation between the tweet length and the sentiment consistency to prove our hypothesis. Our research also has several limitations. The most important two limitations is our Chinese model and English model does not have the same accuracy, and the accuracy of these models affected the analysis of the sentiment consistency of machine translation. So we would think some method to improve on this point. The second limitation of our study is that lots of the neutral tweets were classified as negative. So to add a neutral label in our training data might help improve our study. That's all of our presentation. Thanks for listening. And if you have any questions, please post on our group discussion so we could answer it. Thank you.